Okay, back to Headless Sweeney. So I'm going to show you now how to take out your gel, set up your gel box, and load your gel. So you want to carefully wiggle the comb out, and then you want to just take out the gel. And if there's any like gel that's like stuck to the bottom or the sides, you can kind of just pull that off. And then here's your gel box here, and you have a gel tray, and it's set up so that it's pretty foolproof. You have to put the two notches with the two notches there, and then you have to put buffer in, electrophoresis buffer in your gel box. So we're going to do just a tiny bit over 30 because our gel is 25 milliliters. So you need about 33 milliliters of buffer. You pour it in, and then you put your gel in, and again they've made it so that the grooves fit, and so your gel should be submerged. Shouldn't have any wells sticking out, so you can actually touch it and see that there's buffer on top of it. Okay, sweet. Now we're ready to load the gel. So if you want, you can use this handy dandy tube holder, although it's designed for slightly smaller tubes than you have, but it'll still work. Okay, so you have this. You can put all your samples inside here. And so you want to have a certain order of your samples. I don't have all the samples, but you guys have between, I don't know, 6 and 7 samples. And then you want to write down on a piece of paper the order that you're putting the samples in. So you're going to write down lane 1 is whatever it is, right? So you have the numbers of the samples, right? And they're going to match the numbers on here. And so that you're sure that you've put every sample in that you have and you know the order. Because afterwards, when you get the bands on the gel, if you have no idea which patient belongs to which set of bands, then it's going to be completely useless to you. Okay, so what you want to do is get a tip onto your pipetter. You're going to change the pipetter setting to 10 microliters. So that's 100, so it's 10.0. So I have to scroll up quite a bit since I was on 2.5. So that would be 10. And so now you'll notice there's a lot more play on the pipette than there used to be when it was only on 2.5. Okay, so I'm going to take my sample. If, like, let's say you dropped it and you got liquid all over the place, like little droplets everywhere, what you can do is just take it and like shake it down, and the droplet will go to the bottom. If you just shake it, you just use a quick flip of the wrist, and you can get it all to the bottom. Okay? So you've got actually 25 microliters in here. And so it's enough for, since you're doing 10 microliters at a time, it's enough for 2 gels in case you screw up the first gel. So I'm going to go ahead and measure it. So remember, you push down to the first stop. You stick the tip into the liquid so that you can see that the tip is in the liquid. And you slowly draw up the liquid. Okay, so that's my 10 microliters. I still have plenty left in the tube in case I screw up. I can do it again. And then you're going to go ahead and kind of hold your hand steady and put the tip just above the well and slowly depress. The sample has a dye in it that will let it kind of drizzle into the well, so you don't actually have to put your tip inside the well. You can just put it just above the well and it'll drizzle in like honey and tea. Okay? Then you want to make sure you change tips. You can use this ejector button, and actually you could dispense it right into your little cup if you wanted to, and then get a new tip and load the next sample. And make sure you're writing down the order of the samples that you have. Okay, when you've loaded all your samples, you're going to take the lid and put it on. If I try to put it on the wrong way, it won't fit. So there's only one way that it fits, and that's with the positive on the far side. So the wells are here, the positive is here, the negative is here. Because DNA is negatively charged, it's going to be pulled towards the positive electrode. You're going to turn on the little power button, and the gel will be running. So it takes about 20-ish minutes for it to run, but what's really great about these gel boxes is they have a little blue light that's built into them. So one of the things I added to the sample was a dye that will fluoresce with blue light. And the dye will only, the dye binds to the DNA. So you can actually see the DNA because there's this dye in it that's stuck to the DNA that will fluoresce under blue light. So you're not going to be able to see the sample right away at all, even with the light on. And you can see I just turned the light on. You won't be able to see it right away. It'll show up in about 10-15 minutes. You'll start to see it. But you definitely want to wait long enough for the bands to separate from each other so you can see the two bands or the one band, right, from the different samples. To take a picture of the gel, or to even, well, you want to turn off the lights in the room too, which will help you visualize the gel. But the other thing is you want to make this gel viewer into a box, and then you could put, like, let's say the gel is done. I'm going to turn it off, and I'll just stick this right over the gel, and then when you turn on the light, you can put the lens of your iPad or your phone right over this, and you'll be able to take a picture really nicely of the gel, and you'll be able to see the bands. So as long as you can see good separation between the bands, and you can see your molecular weight standard has run, if you take the lid off, you'll be able to see that there's a dye in the gel that should at least be halfway down the gel. So you want to at least run it that far. Okay, I think that's good. That's the gel. You take a picture. You're going to write down the genotypes of each patient. So they're either going to be CT, CC, or TT. And then you're going to put that data in the Google Docs so that we have all the patients and all their genotypes, and then we can see whether or not there's an association with any genotype and an opioid addiction problem. Okay.